is it run? Okay. This is Team 5's DES project presentation. And for the students who's not here today, we are taking a video. Our team name is Simikos, and the title of the project is In-Vehicle Infotainment project. So you might wonder why this is not a PDC system, because we named it because we want to wrap this presentation up for the overall DES project, so that we want to include every instrument cluster, head unit, and PDC implementations here. So the main goal of the In-Vehicle Infotainment project is to create a functioning instrument cluster and head unit for a Raspberry Pi using Yocto. We're gonna give you a presentation in the following order. In this presentation, we'll mainly talk about layered architecture and then Yocto, and we'll also give you some simple demonstration at the end of the presentation. So the hardware and software setup. Our PiRacer have gone through a big hardware change since instrument cluster project. On August, we assembled PiRacer. We placed the DSI LCD to show dashboard that show the real-time speed data received from Arduino via CAN and then on October we attached another HDMI display to show the head unit implementation with some cool features like ambient lighting and gear selection, media play, and turn indicator, and so on. And lastly, December we installed distance sensor and the camera for the parking distance control, and there you see we are testing our PDC system in HDMI screen. Now about the hardware, the only change from head unit project is adding distance sensor and camera, and the hardware diagram you can find it on our GitHub, so that if you want to know deeply about it, visit our website. And about software, these are some important concepts we've used in this project. And about the COVESA, we use the Common API framework and the vsomeip communication. And Yocto, we used Kirkstone version to implement our system environment. For more information, this is our GitHub organization. These are two big repositories that we've organized our results of the project. We took a lot of time organizing this repository, and there's a cool demonstration video, so please check later.
I have a question.
Oh,
what does COS mean?
COS, in KMU, Kookmin University in Korea, there's a big
5 different universities organization, but I forgot the exact.
it stands for Convergence and Open Sharing System.
Okay.
Yeah. I don't know why I remembered it. Okay.
Why did you choose the name?
Actually he did.
There's not much reason, because he was from Ina University and I was from Kookmin University, so I was trying to think about the name of 2 different universities, and we just choose the name of the organization.
And this is our system architecture. I try to put more detail in software architecture than the prior one, and note that these red square indicates data source, and this gray square indicates process. So we have 9 separated process, and we adopted the star networking topology. So I'm gonna explain more about that when I explain IPC Manager, which is in the middle. And this pink line and black line inside the process means data flow, and this navy color, sky blue color arrow means the inter-process communication. Now, CAN sender receives CAN data such as speed data, distance data via CAN bus, and PiRacer sender receives battery data from I2C. PiRacer controller receives gamepad control input from gamepad. Now, all this data is now transferred to IPC Manager. This time, the big update of IPC Manager is that it does not only work for the intersection of the data, but this time it also works just like an engine. So it's the so now it's the heart of the system. It stores important current data in the PiRacer class, which is my customized class. So it holds the current data, and also it sets the throttle, or it sets the steering directly to the hardware. Instrument cluster, we've done this long ago, so there's no major change. And about the remote speaker, this is for parking distance control, sound alert feature, and I'm gonna talk about that when we do the demonstration. Now we have both head unit and PDC unit. Head unit is for the application window for the previous head unit, and PDC unit is a new one that can show the vision of the backward of the car, and also it shows the distance indicator on top of the camera screen. Now the important thing is that both head unit and PDC unit sends its application screen toward the IVI compositor, In-Vehicle Infotainment compositor. Now this works as a separate process and receives the screen data from both head unit and PDC unit. This is implemented by using Qt Wayland compositor. Now it's time to explain you what is layered architecture mean. Even though we could implement both head unit and the PDC unit in the single process, even though we can manage the layer inside the one single Qt project, but we try to imply the meaning of studying real in-vehicle infotainment, and by separating these two applications into two different processes, we can separately control each process, but at the same time we can show both screens in one process. Now, when the PDC mode is off, the head unit screen is on top of the PDC screen, and this is handled by the Z value of the layer. Now this time the Z value of the head unit is 1, Z value of PDC unit is 0. But when the gear mode is changed to reverse mode, then the PDC mode is on, and then the layer switches its position so that the PDC unit appears on top of the head unit. Now you can see the back side of the car, and also you can see the colored distance indicator that can tell you how close to the wall or how close to the obstacle. Now, Yocto.
Hi, you're back in Yocto. Actually, the Yocto has not been the change much, but the one who listened about Yocto first, I'll do a quick summarize. So Yocto is for making custom Linux for fit to our in-vehicle infotainment system. So if you follow our GitHub, maybe using few 5 or 6 commands, you can reproduce our project exactly same. So now this is our layer for our in-vehicle infotainment. So in this layer, not much things have been changed, but I changed the structure of our GitHub, so I'm going to explain all of it. So the recipe environment. As the same in NetUnit, the Wi-Fi setting or some CAN SPI to communicate with PiRacer and something like that. And also we install Qt, but last time we just installed just a Qt, but this time we install Qt Wayland and Qt Compositor. And because of the Qt Wayland, we were using X11 server, but instead X11 we changed it to the Wayland. And also lastly, the Raspberry Pi config setting. And next, the recipe kernel and connectivity is for changing the Raspberry Pi kernel version. So if you check the issue number 1211, you can check why I changed this. And third is recipe PiPi. Reason why I changed it to the PiPi is that now we are just installing the PiRacer, but later, maybe because of the Python 3 OpenCV, I think I have to install more PiPi package, so I change it to the recipe PiPi and install every dependencies of PiRacer. Lastly, we install recipe IPC, but a little bit issue. However, we install the vsomeip and common API packages in the Yocto. And the recipe modules is actually every core of our project. So our actual code of in-vehicle infotainment is in the recipe modules and also about the AUTOSAR part. We auto-start our IVI program by using Python 3 supervisor. And that Python 3 supervisor not only auto-start the program, but also make the process safety. So even though some process dead, the Python supervisor makes that process run again. And lastly, this is recipe cores. In shortly, every BB file that I make is installed in image by this recipe cores, and this recipe cores is the actual BB file that I run by Bitbake, and this BB file makes the Raspberry Pi image. So now it's our live demo time. Yeah.
Can I ask something?
Yeah, sure.
You said that you are managing your application with supervisor, right?
Uh-huh.
And you also managing your PDC with supervisor?
Yeah.
But the actually the PDC in the application in the heading, right?
Pardon?
The PDC,
Mhm.
the camera images need to be managed in the heading because it is heading the application, right?
Yep.
But do you have any reason to manage the application in the heading with the supervisor?
Yeah, it is true that I think we have to go back to the architecture part. Let's go here. So now they are shown in one IVI compositor, but still they are separate process. So we think that the managing the process is done by supervisor. It is
Yeah, exactly.
Mhm.
Yeah, but actually the PDC unit is for the head unit, right?
Yeah.
And I think the head unit need to manage the PDC unit, but you're managing the PDC unit in the supervisor, like you managing the some cluster also.
I think my answer is not be that good, but actually at the first time, the IPC manager managed every process about our system, but in that if we do like that, if IPC manager dies, then it takes too many times for reboot every process.
Yeah.
So we just use Python supervisor and give every ability for managing the process to the supervisor. So that's maybe the answer about it, that questions.
Sorry, from what I remember is that in your last project, the IPC manager was responsible for doing the exact supervisor thing for your applications. Is it still doing it right now, or the supervisor?
You mean the IPC manager?
Yeah.
Yeah.
Because from the last project, it was using some shell script to kind of check.
No. Yeah, that's just we did the shell script to run the IPC in Raspbian, but in Yocto we use the supervisor.
Okay.
So yeah. So at the last project, it also runs by supervisor every process.
Okay.
Yeah.
But so I'm a bit confused. What is the responsibility of this IPC manager right now?
Similarly, like in the head unit project, it works like an intersection of data, but also this time it also stores the latest data.
Okay.
And inside the PiRacer class, there is also a Python binding to manipulate the PiRacer hardware.
Okay.
So, for example, if the PiRacer sender process sends the battery data, no, that was the example. Yeah, PiRacer controller receives the joystick input and it sends to the IPC manager. Now, IPC manager stores the current throttle or steering input. It stores it inside the PiRacer class, and at the same time, it sets the sorter and the steering to the PiRacer hardware.
Okay. So IPC manager sets the throttle.
Yes, there is a Python binding inside the PiRacer class.
Okay. So, if I'm right, sorry, where does this battery information come from?
In case of
from
battery,
another application.
in case of battery, it's from PiRacer sender.
Okay. So those are just like readers, like reading the information from the vehicle itself, and then it doesn't really set anything.
Yes.
Okay.
Well, we did a lot of experiments, and we found out that it's not a good idea to do a lot of things in a single process when you use Python binding, because it's a high risk of making a segmentation fault.
Yeah, the interpreter.
Yeah. So yeah, we discovered that that's kind of dangerous implementation. So for the battery, there's a whole single process. For the gamepad, we have another process, and for the control of the hardware, we have IPC manager.
Okay. So every other application that requires some data from the vehicle, it kind of asks the IPC manager.
Yes.
All right.
I'm gonna show you in the demonstration, but one reason is that PDC unit requires steering data, because according to the steering value, it shows the distance indicator with some angle. So PDC unit continuously require steering data from IPC manager, and IPC manager will return the stored data.
Okay. Finally, is it using attributes, or is it still using methods?
Well, there is no update about that.
Okay.
Now,
methods.
if you see our GitHub, you can still find out that all of our IPC is done by method code,
Okay.
and that is what I think. I think there is where this project can improve more.
I'm just asking.
Yes. Yeah. Yeah.
Do you have any exception process for disconnecting with the joystick?
Exception.
Exception process.
So
Like when you throttle the car,
yeah.
and when the connection is broken,
Yeah.
the car will stop or just going forward.
Uh,
Because you're separating the joystick and the throttle and steering process.
yeah. If
It's called like drive-by-wire in the rear door.
yeah.
Or do you have any exception process?
Yeah, I don't think I have any handler to deal with that exception situation. Actually, we have never experienced that kind of.
We have that. We now have that test case, so I'm not sure what happened.
But I assume that PiRacer, if we don't update any other data, then it will keep its last motion. So if we lose the connection of the gamepad, this will keep running. Yeah. Okay. Yeah.
If there's no questions, let's start the demo.
So the
Yeah, that was
okay.
it.
So
And don't crush it. It's fragile, so.
now the fix from the head unit project, there was a big delay of controller communication, but this time it is entirely removed by changing the binding structure. Now it runs with no delay. And another thing is that now we can change gear selection and also this turn indicator using gamepad. Now we changed the PiRacer package. We are now using extra buttons on gamepad to control the buttons on the head unit. Now currently the touch input is muted in the code. So if you want to, if I want to reuse the button by heading it, the touch input, then we can just uncomment the several codes inside the head unit code. And some feature that was inside the head unit project was this turn indicator, and the turn indicator is now disabled by steering, just like the real vehicle. Just like that. And the most important thing is that we now have the PDC screen.
But there's one issue about it. Because of the installing the GStreamer in Yocto, I can understand, but the processing is now, there's no problem about the processing, but there's a problem that Wayland actually show in the window. So it is not, it actually updates in 4 seconds, 1 pictures per 4 seconds, but still the process is working well. So we'll show that this is not, now this process is not a problem, just showing the camera is some problem. So will show the blinking sound that we had shown in our architecture now. So let's wait for some SSH connection. And also we can change the change it. And in head unit there's a problem for maybe. And so head unit has the same speed for showing the weight and compositor, but if we do that, we cannot run the video. Instead, in the PDC, we can show the video, but it makes very slow. So it is problem of Yocto maybe. So we will show the sound about it.
Okay. So about the remote speaker, this is a warning sound for the driver according to the distance data. Now you all recognize this sound, right? This is a default beep sound from the Ubuntu terminal. And my idea was to use this sound as a PDC warning signal because there is no onboard speaker or external speaker hardware attached to the Raspberry Pi now. So now this laptop is connected to the Raspberry Pi using SSH. And if I run the remote speaker process, which is inside the PiRacer, now it's running.
Yeah, so this means the process is working well, but now the drawing the image in the wayland window is slow. And so if it turns to yellow, it sounds like this, and if it turns to the red, maybe this is the yellow.
If you're using vsomeip, it is possible with using the external connection, but why are you using the SSH?
Well, we did not think about that. Yes. And also if it shows, and if the steering goes like that, and maybe it will show. So this PDC is following the steering data like this. Yep. Does anyone want to try?
Okay, so steering and throttle, I guess.
Oh, actually, turtle is now like this.
Oh. Okay, reverse.
So in your architecture, it is not possible to manage the PDC in the head unit application?
Actually, not possible, but we are not doing that.
But if you have some issue of the delaying of the video player, then you can try to not rendering the camera image, or that kind of implementation can be done.
There's still some.
But it is possible when you manage the PDC application in the head unit.
Yeah, but actually in the head unit cannot show the video. Instead, it have a normal speed. So if we connect the head unit and PDC, then the PDC video is
there's
not
a speed
come out.
Yeah. So if the problem is about the computing resource, then you can do like kill the process of the PDC when you are running the player. But that kind of implementation can be done when the head unit managing the PDC application.
Yeah.
That's the application layer architecture for this project. But you're managing everything in the supervisor, then
The switches. Anyone else? No, no.
Yep. This is the end of our presentation, and thank you for listening. Our
Yep.
presentation.